Good morning, good afternoon, or good evening to you ladies and gentlemen, depending on when you're watching the video. Today we are going to do lesson 24, that I can solve word problems using fractions and decimals. Now you might be saying to yourself, well, Mr. Philip, we just did 20 the other day. How come we're doing 24 now? That doesn't really make sense. Well, we're skipping ahead because 21, 22, and 23 are not essential. And seeing that we're going a little bit slower right now, I want to make sure that I hit some of the really essential lessons. What I'm going to do is when I talk through the next few lessons, I'm going to incorporate some of the same vocabulary and things from the other lessons that we're skipping. Okay, and would I expect you to master everything? No, as I typically don't for all our lessons. But I want you to put forth the effort and try it. Don't hesitate to pause the video, try them out yourself, rewind the video if needed. Okay, you can certainly be proactive in your learning. So, let's get started. Our first problem that we are going, well, even before we talk about that, page 32 is your reference sheet in case you need it. Right? Or if you need to, just rewind to the 1 minute and 20-second mark of the video and you have it present for you. We may need it today. So I want to anchor in a little bit before solving those word problems specifically. Okay? Because we're talking about fractions and decimals in the word problems, very similar to our review that we just did, or hopefully you looked at earlier, our daily review for the day. Let's turn 2/5 into a decimal. Now, there's a couple of ways we can do it. If we know that decimals work really well working in tens or 100s or 1000s, because we know those place values. So if we can turn this, let's say, into the smallest one, say tenths, that would solve and make things a lot easier, right? Say take a little time, or a little less time rather. So what number would I have to multiply in order to get to 10? 2. So if I do it to the bottom, I'm going to have to do it to the numerator, giving us 4/10. And as a decimal, right, we know that's the very first place value to the right of the decimal, and there you have it. 2/5 as a decimal equals 4/10. Right? So we could put 4 here. I mean, you could make equivalent fractions, say, okay, now I need to multiply it by 10, multiplying it by 10, and give us 40 or 400, okay, that would work as well. Right? Now, let's say we had a problem that wanted decimals. Well, that was a little different. 5/2. Right? We could do the same thing, say, well, can we get this to tenths? Well, certainly we can. We can multiply by 5. Multiply by 5. Remember, our numerator and denominator need to be the same to give us 25/10. Put it in our place value chart, and some of you are already probably realizing that in the tenths place, here's our decimal, we can't have 25. So we have to bundle the 2 and bring it over to give us 2 and 5/10. Now, another way to do it is that we know that in 5/2, this line, this fraction line, really means division. So I could do 5 divided by 2. 2 goes into 5 how many times? 2. 2 2's is 4. We use 4 of them. Find the difference of those. We're left with 1. Now at this point, we would have to put in our decimal and make sure we line it up. Right? And we know that there's 0 value here. We don't typically write that 0 if there's nothing there. Bring it down. How many 2's go into 10? Well, 5. And we have a similar exact answer there. So think of, you're going to have to problem solve a little bit from time to time and figure out, well, can I make equivalent fractions in using tens, hundreds, and thousands? Or should I just divide? Right? And you could do either strategy if it works. And we're going to find a couple problems today that you could do one or the other or both. So let's do one more in our anchoring in here. And as I scroll down, what is 6/20ths? Now here's a great time for you can pause the video and try to solve this on your own and then play it back. You could do it in an equivalent fraction. And I could go in tens, hundreds, or thousands. I like to multiply, so I might try to do hundreds. See what we come up with. Well, 20 times what will give us 100? 5. So we have to do it to the top as well. There's a basic fact giving us 30. 31/100ths is a decimal. 30, and then the hundredths. You could certainly say it's 3/10. They mean the same. They're equal as well. If you didn't want to do it this way, we could do 6 divided by 20. I already know that I'm not going to get any of them in there. So I'm going to have to put in my decimal point and make sure that I line it up. Very important to do so. So I knew there were 0 of those, so I'm still left with a 6. I'm going to have my 0 here in my tenths and bring it down. How many 20s go into 60? Well, 3 of them. 3 20s is going to give me exactly 60. And when we find the difference of those, we're left with 0. Again, there is your answer, and it matches. So let's use this information to help us with our word problems. I'm on lesson 24 problem set, page 103. If you don't have this, you can use a scratch piece of paper. And I'm going to jump down to number 2. Depending on how long the video goes, we'll do 2 and number 3. We may just do 2. We'll wait and see. All right. So let's solve it. A container holds 7/10 liters of oil and vinegar. 3/4 of the mixture is vinegar. How many liters of vinegar are in the container? Express your answer in both a fraction and a decimal. Well, what are we referring to in here? All right, we're talking about a container, right, and how much it holds. There's our gist. Our details, well, we have 7/10 liters of oil and vinegar, and we need 3/4 of the vinegar. We want to do it in a fraction and a decimal. Well, good to know. The next step in our RDW process, maybe even write it over here. Just read it in our D&W. I tend to switch it around and do RWD because I like to do that sentence first. It has that label in it. Right? How many liters of vinegar are there? Well, I might say there are blank liters, and it's just a capital L. And you can write out liters if you need to as well. There are blank liters of vinegar. Now, it doesn't matter what your sentence would look like as long as you have the liters in there. So now let's solve this. I'm going to draw a picture. I tend to love drawing pictures. Here's my beautiful, hopefully neat and organized model. Right? And I want 7/10 because that's how much this container holds. So I'm going to split mine in tenths. 2, 3, 4, 5, 6, 7, 8, and we got to squeeze in the 9th there. Double check to make sure that you have 10 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very good. And we have 7/10 of those. So I'm going to use my highlighter, and I'm going to highlight 7 of them using the side of my pencil, or the side of your pencil. Let's shade that in, make sure we have just those 7. Right. And as I do so, I will also label my work too. I noticed that a lot of work lately has been coming and sent, uploaded to me without labels. And just get in the good habit of making those labels. Just makes it a little bit easier. So here's my 7/10. But I don't want all 7/10. 3/4 of the mixture is vinegar. So I'm going to then decompose this into 3/4. There's my 4 parts. I only want 3 of them. 1, 2, 3. Now I would say that you could do the battleship method. Okay, coming here, following up, okay, following across. Right, and those are the pieces you need. Some of you, if you're shading it, okay, you're shading just the 3/4, so we'd be shading all of this. We'd be shading all of this one. Gotta get better at my shading. And I would be shading all of this here. We would have to then take a look at what is being shaded twice. And you'll notice with mine, I have a different colors to it. Right? So yellow was my 7/10, my blue was 3/4, but I want what is shaded twice, which happens to be, if Miss Lawrence would be quite proud of me, and make green. So what do I have left over? Well, I have an array of 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. 7 times 3. We have 21 shaded pieces. How many are there all together? Well, there's 4 going up and down. There's 10 going across. 4, we have our, well, let's do our 10 times our 4, and it gives us 40. So there is our fraction, 21/40 of a liter. Now notice how I did this. There's our 7/10, and there's our 3/4. We just used that strategy of multiplying straight across. Now the next part, because it asks us to do it in a decimal as well, let's put 21/40 as a decimal. Well, I'm going to have trouble putting it into tenths or 1/100ths or 1/1000ths because it doesn't really work as well. So here's where I might go ahead and just do 21 divided by 40. And how many 40s go into 2? 0. I know that some of your parents or guardians at home might say, well, just put zeros here and keep going. I like to just stay neat and organized, make sure I line everything up, so I put the zeros here. And we'll bring down the 1. How many 40s go into 21? 0. Still left with 0. Or excuse me, still left with 21. Now here's where we have to put in our decimal. Line it up. And we put in our 0 as well here. Bring it down. How many 40s go into 210? Well, if we're not sure, we practiced in Module 2 and 3 just taking 40 and skip counting it. 40, 80, 120, 160, and 200. Well, that's close because the next one's going to be 240. So I need to do 1, 2, 3, 4, 5. I'm going to do 5 of them. And that's going to give me 200. And when I subtract, I'm left with 10 left over. Now I'm going to have to put in my 0. Where'd my marker go? Put in our 0. Bring it down. How many 40s go into 100? Come over here. Well, it looks like only 2 of them, because 3 of them is going to be too much. So I'm going to put a 2. 2 40s is going to give me 80 of them. Finding the difference of those, I know that mentally, is going to give us 20. Still not done. Put a 0. Bring it down. Oh, that's nice, because now we have 200. And skip counting over here, I see we already used 200. Okay, that's 5 of them. I'm going to put a 5, knowing that there's 200. And when we find the difference, we're left with 0. And now we have our decimal. You will notice through your work that if your decimal goes longer than 3 place values, you can stop at just that thousandths place, the 3rd place. And typically, that's what we do and expect for fifth.